Welcome to day 33. Until now, when our code hit an error, it crashed. In the real world, a crash means a lost customer or a failed server. Today, we learn how to handle errors gracefully using try and accept. First, understand the difference. Syntax errors are like bad grammar. The code won't even start. Runtime errors, or exceptions, happen while the code is running, like trying to divide by 0. These are the ones we can catch. The try block is your safety zone. You put the code you're worried about inside it. If an error happens, Python looks for an acceptor block. Instead of a red error screen, your user gets a helpful message. Let's code a calculator. If a user tries to divide by 0, Python raises a 0 division error. By catching this specific error, we can tell the user, hey, you can't divide by 0, and let the program keep running. Another common one is value error. This happens when you expect a number but get text. We'll wrap our input functions in try except to ensure that our program doesn't die just because a user made a typo. A single try block can have many exceptions. You can catch a value error for bad input and a 0 division error for math errors separately. This allows you to give very specific feedback for different problems. Pro tip: avoid using a bare except. It catches everything, even mistakes you didn't mean to ignore. Always try to name the specific error you are expecting. It makes debugging much easier later on. Sometimes you want to see the original error message. By using except value error as e, we store the error in the variables d. We can then print d to see exactly what Python's internal engine is complaining about. The else block is for code that should only run if the try block was successful. It separates the risky logic from the follow-up logic, making your code cleaner and easier to read. Finally is the cleanup crew. No matter if your code succeeded or crashed, the finally block always runs. This is where you close files or disconnect from databases to prevent memory leaks. Let's build a reusable function called get_number. It will keep asking the user for input in a while loop until they provide a valid integer. This is a professional pattern you'll use in every CLI app. We'll explore how putting a try except inside a loop allows the loop to continue, even if one iteration fails. Useful when processing thousands of rows of data, where a few rows might be corrupted. What happens if an error occurs inside your except block? We'll look at nested try except structures. While they look complex, they are necessary for multi-layered systems like network requests. I'll use a diagram to show you exactly how the controller jumps from the try line to the accept line, skipping everything in between. Understanding this jump is key to mastering logic flow. Today we moved from being coders to developers. You now know how to build software that doesn't break. Tomorrow, we go further by learning how to raise our own custom errors. See you then.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.